10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Stage 1 propulsion nominal.
T plus 35 seconds and counting, and we are well on our way to space. Our 53rd Electron rocket has taken flight, and it's headed to orbit with its payloads for Kineis. Up next, you'll hear the call for max Q, or maximum aerodynamic pressure, the point in flight where Electron experiences peak structural load. The GNC operator on console will give us the call that max Q is approaching, and then we'll hear for confirmation that we have passed through that gate.
HVB discharge is nominal.
Cleared max Q.
And there we have it. Confirmation Electron has passed through max Q. We are now at 19 kilometers altitude and traveling over 2,700 kilometers an hour. And next up, we have 3 key events: main engine cutoff, or MECO, stage separation, and stage 2 engine ignition. MECO is when all 9 Rutherford engines shut down to prepare for the next phase in flight. And after those engines shut down, Electron's first and second stages separate. Then finally, the vacuum-optimized Rutherford engine on Electron's second stage ignites to propel the mission through to an elliptical transfer orbit. Those 3 events all take place in a quick succession over just a few seconds, so let's listen in for those calls.
"15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
We are now T plus 2 minutes and 45 seconds into the mission, and as you've just heard, Electron has had a successful MECO, stage SEP, and second stage ignition.
Stage 2 guidance.
Telemetry data shows that Electron is now moving at over 8,200 kilometers per hour and has just passed 100 kilometers above Earth. Up next is fairing Jettison, when Electron's nose cone, which is protecting our payloads today, will split in 2 and fall away. We might see this happen on screen, so let's keep an eye out for that.
Fairing Jettison succeeded.
And that was the call out for fairing Jettison from Mission Control, exposing the payload to space ahead of deployment.
Stage 2
Electron is traveling at over 8,500 kilometers an hour at an altitude of 125 kilometers, with just a few minutes remaining in the second stage burn.
Now, if you take a look at the graph on the right-hand side of your screen, then you can see Electron's current trajectory compared with our expected trajectory. And we like those 2 lines to be as close as possible, and that's what helps Electron's precise payload insertion accuracy.
HV discharge nominal.
Some of you may be wondering how IoT satellites
Stage two
impact
propulsion
your daily
nominal.
lives. These satellites connect devices globally, even in areas without regular internet. In day-to-day life, this means you can track deliveries worldwide and carry out credit card transactions, even if you're stranded in the middle of the South Island of New Zealand. They also support things like your smart home assistant or fitness watch, allowing them to stay connected anywhere for real-time updates or alerts.
Now, one of the things that sets Electron apart from many other rocket designs is the use of electric pumps in the Rutherford engines. And those pumps
Guidance
are powered
is
by
nominal,
batteries,
200
which
seconds
deplete in
remaining.
power throughout the flight. Once we use up all the available energy in one set, we'll switch to a fresh battery to complete the mission all the way through to orbit. And that maneuver is referred to as the battery hot swap. After the first set is depleted, Electron won't need those batteries for the remainder of the journey, so we jettison the depleted batteries to save mass in the final stages of flight. That's coming up soon, so keep an eye on your screen and see if you can see the shiny silver batteries eject and fall away.
HV discharge nominal, approaching hot swap.
Throttling down.
Battery jettison confirmed.
And that was the call for battery hot swap on the second stage, confirmed as successful by Mission
Hot swap
Control across
successful.
the nets. Up next is the final stage of Stage 2 flight, including SECO, or second engine cutoff, followed by kick stage separation. This is where the kick stage, carrying the 5 Kineis satellites, separates from Electron's second stage. That final engine cutoff is coming up just shy of 9 minutes, so only about 3.5 minutes to go.
Stage 2
HV says
propulsion
saved.
holding nominal.
Now, electric pumps on Rutherford offer other advantages other than just a simplification of design. Now, these groundbreaking pumps can run the tanks all the way dry, allowing the second stage to squeeze every last bit of performance out of it during flight. And those pumps on Electron's second stage are currently powering us at speeds of over 19,000 kilometers an hour.
Some keen watchers from Flight 50 will remember some fun flips and rotations the kick stage performed during payload deployment for the last Kineis mission. The kick stage's reaction control thrusters achieved this by expelling precise amounts of cold pressurized gas through small thrusters to rotate the kick stage and control its orientation and position in space. It's this system that's responsible for our industry-leading deployment precision.
It's now T plus 8 minutes 18 seconds, and we're fast approaching second engine cutoff. And just before that happens, the Rutherford engine will begin to throttle down in preparation for shutdown, which is scheduled to
Guidance
take
is
place
at
around 9
28
minutes into
seconds
the
remaining.
mission. So let's listen in and wait for that confirmation.
SECO confirmed.